sorry, I was disconnected. Do malware analysis in my private industry position, and during my doctoral program, I wanted to focus on malware and incorporate machine learning. And a part of those studies, I wanted to build a baseline on understanding how machine learning was used in the process of malware classification. So for this study, our goal was to really get a survey of the current state of the art for using machine learning for this particular application of malware classification. So a little background about about malware in general. Malware is software that can cause harm to systems and basically inflict damage on a computer system. And these can be financial damages, they can be reputational damages, as long as it is in conflicting some type of harm. That's where the mal from the malicious side of malware comes from. It's actually a conjoined word, malicious software, and they put together and built that word based off of that definition. Malware is a serious problem. There's over malware costed $6 trillion in 2021 from cybercrime against their victims, and in 2021, I've seen over 1 billion systems infected by malware based off of the A/B test reporting. A little bit about machine learning. Just to give a baseline, machine learning is defined as the capacity for a system to learn a problem specific data source and automatically build an analytic model to solve a task based off of that. Machine learning is a very popular subject. As you all may know, in academia, it's quite often used to solve a wide variety of problems that we are presented in life. And as of December 2022, if you look in Google Scholar and you do searches for machine learning, you'll see over 5.4 million results, which is pretty significant because machine learning is a fairly new field of study as of, as of recent. And so having that much knowledge and literature created around it is, very significant in how much impact it's had on the global knowledge. So the goal of this study was to really understand what type of machine learning is used for malware classification. If I were to pursue and look to do research in this field, I really needed to understand what the current state is and where people are currently doing research, and potentially identify areas for improvement or gaps that can be filled through my research so that I'm providing extra value towards the overall knowledge for the particular subject. And why is it helpful to use machine learning for malware classification? Well, honestly, machine learning is typically faster, and malware classification is typically a faster type of detection mechanism. So doing static analysis against a piece of malware to understand whether it's good or bad versus doing dynamic analysis is a lot faster, because you don't have to watch the malware run and look at its behavior in order to infer the malicious activity to determine whether it's a good or bad type of outcome from that binary. As well as it's safer. So uh, static analysis and classification techniques are safer than actually running the malicious piece of software in a even sandbox environment, because there are sandbox escapes. Having something actively doing something malicious in any environment brings on inherent risk. So being able to understand and in a fast manner whether a particular piece of software is good or bad is very, very important, and I think something that's novel to pursue. And so that's why my theory was that there's a lot of current knowledge around machine learning and malware analysis, and being able to leverage that current knowledge to understand where I should take my research would be helpful here. And as I said before, it'll align with future research. So where should I be looking? Should I be looking through the gaps of what things are not being currently looked into from academia, or should I be exploring certain subjects further? Through this survey, I was looking to answer three key research questions. Is the application of machine learning for malware classification growing? So are my assumptions that this is a growing field and this actual application for malware classification is actually increasing over time? Are they true? The next question is, what are the most common machine learning applications used for malware classification? So what are actually the ways that people are actually applying this technology towards this problem? And then lastly, what are the outcomes of the most common machine learning applications? What are we getting from this? What are the benefits to society for knowing and being able to leverage this technology to complete this task and address this problem? So those are the three things that we were looking for in the research here. Now, as I did this meta-analysis, I started by making sure that I pulled a very strict set of data from academic databases. So we created a query where we looked for the combination of malware classification and machine learning in the metadata of these articles, and we pulled from four different sources: Web of Science, IEEE Explorer, ACM, and Science Direct Elsevier. And through this, we were able to pull out 2,558 matching articles. We did time band that, so we time band it from 2008 to mid 2022 to make sure that the volume was pretty current for our analysis. From there, we actually went through a text mining process. So we took those 2,558 articles and we used a couple different tools in order to pull information, organize, and filter out certain articles based on our conditions. So I leveraged a lot of Python, so pandas, and using Jupyter notebooks in order to pull the data from from the CSVs that we created out of Zotero, which is a citation software. And then I used Plotly to create some of the graphs in NLTK in order to extract stop words and do some of the n-gram analysis against the data set. And with some of the filtering that we did, and the processes here on your right, we were able to constrict our articles to 2186 articles based off of either being outside of our time bounds, not having a direct enough of a direct enough relationship towards the topic or terms that we were looking for, as well as some things that were not classified as publications or articles, or they didn't have a large enough set of words within the content itself in order for us to think that it would be reasonable to do meta-analysis on this in aggregate. So when we look at the techniques that we used, we first did a quick temporal analysis. We wanted to understand, we want to sort of address the first research question. We want to understand the trend of using malware analysis for malware classification, machine learning for malware classification over time. Is this an increasing trend? Is it pretty steady trend, and how does this look from a temporal standpoint? And then we did some frequency analysis to understand what types of terms we're seeing often across the different articles. With 2,000 articles, obviously that's a lot of content to go through. So when we went through our meta-analysis, we really focused on a finite set of observations that we want to take in order to understand from a general standpoint, which articles we should focus on and what type of trends or artifacts we were wanting to pull out of the data set. And then lastly, we did n-gram analysis to get some stronger relationships between the terms and some of the themes that we were pulling out towards the articles, making sure that the word machine or something along those lines weren't actually unrelated to the actual terms that we're looking for. We wanted to see strings of terms that really had a direct correlation to things that we were interested in the data set. So the first part, temporal analysis, you can see the article publications over a year, and this actually helped us understand that this actual trend is growing over time. So we can see that in 2008, we did not have a lot of articles. And then going up to 2021, we saw a lot of articles. And when this data was pulled, mid 2022, we saw that this trend was going up. So this is a partial 2022 timeframe. That's why you see the slight dip at the end of the chart, but we can see the general trend going upward. And obviously, we think that we thought that this was due to the machine learning application being applied to a lot of different areas of study. I think a lot of people are understanding and being able to develop uh, mechanisms to leverage machine learning to solve a lot of problems broadly across academia. And so we would assume and shown through this graph that this is actually also a trend for malware classification as well. The next thing we did was frequency analysis. So we looked at the different words that we're seeing within the articles. So we took all those 2000 plus articles and we wanted to say, what type of things are we seeing commonly? What type of things should we be honing in on, looking and investigating to see if we can pull more insights that are going to be relevant to our study? So the first thing that we looked at was the frequency of title words. Obviously, there's a direct correlation between the title words and some of the data from the search terms. And you could see this with the machine or the malware aspect of things being the highest count. Learning is going to be a high count there. One of the interesting parts is that we can see, and I'll move over to some of the correlations, that we see something like detection that comes up because, in our search term, we did not have detection a as a term to be looking for, but obviously it has a strong relationship. And when you look over to the abstracts words, which are we pulled out all the words in the abstracts of every single article, and then we counted them and built this table from that. We can actually see that detection also has a relationship there as well. And then, classification, learning, malware, machine, they're pretty common and you'll see them there because those are in the search terms. So it was really interesting that we were able to pull out some of these correlations with our word frequency, and we were able to really hone in on, well, detection may answer some of our research questions based off of this observation from the data. We went through and developed a word cloud based off of these frequencies from abstract words. The reason why we chose abstract words, and we made one for title as well, but the reason why we focus on the abstract words is because that had a larger data set for it to identify particular trends. Some articles will talk about malware multiple times within their abstract versus, a title, which would have typically one of each term that it's going to be mainly focusing on in there. So we wanted to sort of show the weight of the terms that are being used and how heavily they are being referenced. And as you can see here, there are some strong correlations. So classification, malware, learning, those things from our terms, those are obviously showing up. But then we also get feature detection comes out again in a model, which gives us a lot of hope that we're going to be able to pull out additional insights from this article data set without even having to deeply go into the articles yet. So we haven't even looked at the articles. We're just pulling out data, just looking at the metadata and doing that meta-analysis. From there, we went into a bigram analysis of the abstract word. So these are combinations of two terms in the abstract. So we wanted to get an understanding of how often two terms were seen next to each other within those abstracts. And as you can probably tell, machine learning would be very, very prevalent there. But the interesting part here is that we see the correlation of malware detection, neural network, deep learning, random forest, support vector, and convolution neural they're actually showing up high on the list here. And that's really good because we can actually identify those as different applications in machine learning and different objectives of malware analysis. So part of malware analysis is to detect whether the presence of malware is there, and that's the classification of whether it's good or bad. So these things are actually giving us a insight as to the 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 overall deeper investigation of those articles, and we're able to understand what type of studies they're doing on a smaller level. So it's giving us a stronger correlation to the machine learning applications that we're seeing. So we're pulling out some of those things and we look through some of those correlations. But we actually wanted to go a little bit deeper, and we did a trigram analysis of the abstract words, and we were able to even get stronger correlations where we got support vector machines, convolution neural networks, deep learning neural network, and machine learning classifier. And these are very, very promising because obviously support vector machines is a well-known machine learning algorithm and application, and convolutional neural networks are as well. So it's very, very promising to see these because it allows us to understand and be able to pull out those as trends when we're looking at malware classification and how machine learning impacts the study of malware classification and how it's being applied to malware classification. Uh, Lastly, from the n-gram analysis, we did the 4-gram analysis, which is this 4 words. And this is where we were able to come down to the strongest set of machine learning algorithms that we saw in the data set, and that's support vector machine, convolutional neural networks, decision tree, random forest. I sort of pulled those together because random forest are actually a combination of decision trees, and these as the most common ways that machine learning are applied to the task of malware classification based off of our data set. So from there, we really needed to understand how each one of these impacted our data set from a broader level. So what we did was we took those terms and we actually did a search across those articles to find the articles that mention in any way, shape, or form those terms. And we identified that support vector machines are the most commonly mentioned, followed by random forest, which are both classifier type machine learning algorithms. And then we have convolutional neural networks and recurrent neural networks in the lower half of that analysis there. So when we look at random forest, it's a type of decision tree algorithm that uses an ensemble of multiple decision trees. This is why we sort of bundled those together to improve the accuracy of the model. It works by randomly selecting subsets of data to train each decision tree and then averaging all the results to get its final prediction. And this helps with just making sure that you're not overfitting your data set and you want to have better accuracy, because that average, they're going to say that generally the best of the common are gonna make its way to your overall prediction. We saw 66 articles from this data set that called out random forest and decision tree, and it was the second most common. The some things that we put in the articles. So we started the insights that we found was that random forest is probably the most cost effective of all of the algorithms that we studied here, mainly just the way that it is using the training set, and it's sort of very autonomous in that function. We also know that a lot of these applications were typically using larger public data sets, and they would be pulling out static artifacts or features from static artifacts from those public data sets. So they would be looking at large malware data sets that already had features defined in that data set in, typically a CSV format or a database format. And then most of those papers would just apply random forest towards them, which was an interesting insight that I found while reading through these articles that particularly mentioned random forest. Support vector machines are a type of supervised learning that you can use for classification and regression tests. So the algorithm finds the best boundary between the different classes of data, and this boundary is sort of used to maximize the margin and make sure the difference between the boundaries and the closest data set for each class is that support vector machine. So that boundary, that margin is called the hyperplane. And this is actually the highest accuracy compared to most machine learning models. But from the articles that we were reading, we actually found that they're really this type of machine learning algorithm is really good at determining whether something is malicious or not malicious. So that binary verdict, but not good for cloud categorization. So if you're wanting to classify malware based off of its functionality, behavior type, group, author type, or endpoint or directive, those type of things, you would actually not want to use this algorithm. This is really just good for the direct, is this bad or is this good? This is also the most commonly used machine learning application for malware classification. And I think this is one of the things that we really point out as the one of the most broadly and impactful for malware detection, because a lot of times you're just looking for, is this bad or is this not bad, and you want to do this fast. So this is pretty fast, it's pretty accurate, and it gives you a good sense of whether something is good or malicious or not malicious from that standpoint, which makes it very favorable for this type of application. Convolution neural networks are a type of deep learning algorithm that are commonly used for images and videos. They apply a series of filters on the input to extract features and then use those features to make prediction. So they're really effective for like images and videos and recognizing there are certain things in those images and videos. There are only 9 articles that really represented convolution neural networks, and they're typically were image-based representation of the malware. So they were looking at, what it looked statically. So it would be like an image of the malware data, or they would be using something like an application of its usage on an IoT system. I think there was one instance where it was looking at the heat map of a actual IoT device to identify whether it was running malware or not, and then also mobile applications. So we found in our reading of these articles that it wasn't directly addressing Windows desktop malware, which is our focus of our study. Recurrent neural networks were the other type of, and the last type of algorithm that we looked at, and there were 37 articles that addressed this type of algorithm. And recurrent neural networks work similar to convolutional neural networks, but it also features a feedback loop, to allow for forecasting. So it actually learns a little bit from the data that it makes through. And it mostly is used for dynamic features of malware, so data sequences. So we saw that it was being used for opcode sequence analysis and also behavioral heat maps. So what types of functions, calls, APIs the malware is using at runtime. So this was a dynamic based data set that the large majority of these articles were actually using from our end. So with that, we actually favored the other applications, such as support vector machine and random forest, because of it's the dynamic nature of this and it being slower and also more risky. So when we look at the answers to the research questions that we aim to answer throughout our study, we wanted to know, is the application of machine learning for malware classification growing? And I think we can answer that that's yes. Just looking at this chart, we can see the apparent trend line going up, and we would have to presume that will keep that trend over time. So we were able to determine that it is worthwhile continuing to look into this technology for this type of application, specifically machine learning for malware classification. We also wanted to know what is the most common machine learning application used for malware classification, and based off of our article count at the bottom corner here, we were able to understand that support vector machines were the most common application for machine learning in malware classification. We had 103 articles within our data set that mentioned support vector machines in their abstract or the rest of their metadata. And we also saw that there was a large difference between support vector machines and random forest, and then even more so for the neural networks. So we were comfortably able to say that support vector machines definitely were some of the most prevalent applications for machine learning. What are the outcomes of some of the most common machine learning applications? Well, based on our literature review and doing n-gram analysis, we definitely could see that malware detection is one of the largest outcomes of this applying this technology to this problem. So machine learning to malware classification, we could see that malware detection rose above many of the other terms when it came to n-gram analysis, as well as the word cloud. We were able to see detection as a prominent feature in both of those analyses. And then we also were able to see in our manual literature review that the family categorization was also another outcome of many of the applications of machine learning to malware classification. So a lot of this fundamental survey study was to help drive future research. We wanted to understand if there were any gaps in the research, and we all know that there's many other machine learning algorithms, and knowing that mainly the ones that are being studied are random forest, support vector machines, convolutional neural networks, and recurrent neural networks, that offers an opportunity for other algorithms to be tested and studied for the job of malware classification, as well as leveraging other data sets. A lot of times those data sets that were used were actually public, well-known malware data sets that have pretty strict format and structure. Being able to use different, more unique structures and data inputs for some of these common applications may be another interesting area of research. And also, in the future, we can confirm prior research. So going down and saying how well malware classification is doing based when you're using machine learning, we can actually go through and target support vector machines as one of the most prominent ways to use machine learning for malware classification, and do research to confirm that this is still. Conclusion for this study, we examined 2,186 articles on malware classification and machine learning. We found that malware classification is using machine learning a lot over time to sort of apply this technology to that problem, and support vector machines and other classifiers were some of the most prominent applications for machine learning to do malware classification, specifically for malware detection and family categorization. And from these findings, it really demonstrates some of machine learning's potential as a powerful malware fighting tool, and emphasize the need for further research here. As you know, malware is still a problem, and if machine learning is allowing us to gain ground, I think that there's a lot of opportunity for us to continue exploring this field. Thank you.